Hello and welcome to Quantum IAS. This is day 8 of our daily answer in program, January. I hope all of you are writing the answer on time. So let us start with the question number 1. Question number 1, state and explain Stokes' law. So whenever something like state and explain, define, right? So when these things are given, the purpose of our introduction is solved. So for the introduction, we just need to write this part. Now next part starts. A drop of water of radius 0.01 meter falling through a medium whose density is that much and viscosity is this much. And we need to find the terminal velocity of the drop of the water. Now, if you know, that is good. If you don't know, that is also good. This detail of the density as well as the viscosity belongs to the air. So it is basically it is a case of dropping of water droplets inside the air. So let us start with the introduction part. So we will also explain it, right? We will not only state Stokes law, we will also explain it. So we will explain that. You can just write on. I will be dictating some few things. So if a body, you can write, if a body is moving inside a fluid, the fluid exert a viscous force or a drag force or a friction force against the relative motion between the object and the fluid, that is known as the viscous force offered by the object, which is can be represented as Fv is equals to minus Cv, right? So if anybody is moving inside a viscous fluid, Fv is equals to minus Cv, where V is the velocity of the particle and minus shows that the force that is acting on the particle or the body is basically opposite to the direction of its motion. Basically, it's relative motion, but motion. Where C is a constant and it depends upon the geometrical factor of the body plus the dynamic viscosity of the medium, right? This is of the medium and this is of the object. So it depends upon the geometrical factor of the object as well as the dynamic viscosity of the medium. And while stating this, Stokes states that the value of C is 6 pi eta r for spherical object. So Stokes states that if a spherical body is moving inside a general fluid that is air or water, always remember, general fluid that is air or water, the viscous force acting by the or the offered by the medium will be equals to Fv is equals to minus 6 pi eta Rv, where V is the instantaneous velocity at which it is moving. Now, this can be your introduction part. In the conclusion part, we will try to write few more things. If you want to write here also for the conclusion part, we will have a specific conclusion for this question also. But for any Stokes question, you have to write. It's a 15 marker. So assumption, what all assumption that we have taken, that the body that we have taken, it is rigid as well as the shape is also defined, that is spherical in nature. The next thing, that whatever the velocity it is attaining, it should be less than the critical velocity. That means no turbulence, right? No turbulence in the flow. And the medium that we are considering, that is infinite plus homogeneous. So these are the assumptions associated with the Stokes law. Also, if you want to write the application, it is basically used to find out the viscosity of the medium. Using Stokes law, you can find out the viscosity of the medium, right? So this can be your intro part. This can be your conclusion part. Also, one more thing will be in the conclusion part that will be related to the question itself. Because one more thing is here, that is the terminal velocity. They have asked about the terminal velocity. So after writing the introduction, you will write about terminal velocity. You can write it out. So terminal velocity is the velocity that a body attain inside a fluid when the net external force balanced out each other and it's moving with a constant velocity. So terminal velocity is essentially a constant velocity. And at this point of time, all the net external forces balances out each other and the body is moving with a constant velocity inside the fluid. Now, the equation of motion, if you want to write, if a body, see, if we have a mass, then we know that it will have mg. And now, if it is inside a fluid, let's say this is the fluid. Okay. Now, understand this is inside the fluid. If it inside the fluid, it will act a buoyant force which is equal to the weight displaced of the fluid. And if it is moving, let's say V, it is moving this direction, then it will apply a viscous force also. So if you write the equation of the motion, you can write m dv by dt can be regarded as mg minus fv, that is viscous, minus fb, that is the buoyant force. Now, we know that the body that we are considering, that is spherical nature, so mass can be split as rho into volume, volume into density, and volume can be as 4 by 3 pi r cube. Rho naught is the density of the object, into g, minus fv is the viscous force acting on it, that is 6 pi eta rv, that we know from the Stokes law, minus fv, that is the buoyant force, is equals to the weight of fluid displaced. So weight of fluid displaced will be equals to the mass of fluid displaced into the gravity, and mass of fluid displaced will be equals to the volume of the object, but we will multiply with the density of the medium, so that it will be the mass of the fluid that is displaced into g. Now, if it is going to attain its terminal velocity, then net force balances out each other. There will be dv by dt equals to 0 because it is constant, and this v tends to vt. And if you arrange these things, you will get vt terminal velocity, that is equals to 2 by 9, and I hope everyone know this formula, rho naught minus rho m by eta. In our circumstances, rho m is given as 1.21 kg meter per cube, and rho naught, that is the water, that is the spherical ball that we are considering about, it is 1000. So it is much bigger than this. So you can also ignore the rho m, but it's up to you. That will not change the answer much. The answer, if you put it here, it will be around 12 kilometer per second. Again, it depends on what you have taken the value of g, 9.8. Try to keep it 9.8. Now, what conclusion you can make here? It is a very high velocity, and this high velocity is mainly due to the radius, and which is given as 0.01 meter. So the spherical water, the radius of it is very high, so the velocity is also very high. And if you remember, we have also draw this graph in the class also. Vt are something like this. It will be parabolic because all the parameters are same. Rho naught, rho m, eta, g, right? All the parameters remaining the same. If you just change the radius of the object, this will be the Vt. So this is also can be written in the conclusion apart from what we have discussed here. So this is all about the question number 1. Let us move to the question number 2. Question number 2 states that a capillary tube having this much in diameter, this much length. So basically, capillary tube radius is given, length is given. Radius is given and length is given. Is connected to a vessel in which alcohol is kept fully to a neck. The density of alcohol is 8 into sin. So density is also given of the alcohol. The depth of the tube is 40 centimeter. So also height is also given. Find the amount of alcohol that will flow out in 10 minutes. Coefficient of alcohol is this. Viscosity is also given. Now, let's talk about the intro and the conclusion part. remaining, it is a 10 mark question. It's a very easy question. Sorry. So in introduction, you have to write about the Poisson equation, and in the conclusion, you need to write about the assumption of the Poisson equation. That's it. In every Poisson equation question, these will be sufficient. Apart from if you can interpret a good answer of the number that you are getting in the final answer, you can do that also. But it is a standard. So you can write Poisson equation states that rate of non-turbulent flow of liquid through a thin cylindrical pipe depends upon the viscosity of the liquid, radius of the pipe, and the pressure gradient. Pressure gradient between the pipe. Now, what are the assumptions? Assumption that it should be a Newtonian fluid that is incompressible in nature. The pipe, the geometry of the pipe should be cylindrical in nature. The liquid follows a velocity profile, that is the liquid that is in contact with the pipe will be at rest. You can write these things. You can the flow will be streamlined and there will be no radial flow. So all these textual things you can write in the introduction as well as the conclusion. Now look at the question. This is the vessel, this is the pipe, and we know the radius, we know the length, we know the height at which the alcohol is also kept, right? We know its density, we know its eta also, everything we know. Now, at any interval of time, the mass will come down here and move out from this side, right? But the Q will remain same. We know that conservation of the mass. So if you write Q that is coming down here, that will be equal to, that is going from here. So it will be equal to pi P4 upon 8 eta L from the Poisson equation. Also from in the introduction also you can write this formula. Mathematically it is given as this, where P is what? Simply rho GH. Pi rho GH R4 8 eta L. Now pi we know, rho is no, G is known, H is also given 40 centimeter, R4 is also given, R radius of this is also given, eta is also given, length of the pipe is also given. So you can find out the Q, that the volume of water flowing in 1 second, right? The volume of alcohol in 1 second, right? So what will be the volume in 10 minutes? So 10 minutes it will Q into 10 minutes into 60 seconds. Just multiplied by 600, right? Now, what will be the mass? The mass that is flowing here, it is also the alcohol. Just multiply volume. Mass will be what? Rho into volume. So rho into Q into 10 into 60. Whatever it comes, this is the answer, right? So again, understand the liquid that is coming out, it is also the alcohol. That's why rho we have given of the alcohol, right? And the liquid that is exerting pressure on the tube, that is also alcohol, right? So that's why we have to take, where is it given? Yes, viscosity is given here and density is given here. Just need to multiply it with this, right? H 40 centimeter is given, radius is given, L is given, eta is given, rho is given, time T is given, right? So simply, so the final answer will be rho Q into T, that will be in second, right? Q is here. Okay. So that's all for the day. We will meet in day 9. Till then, keep writing. Thank you. Good night and bye bye.